So for this video, we will talk about cables. Okay, so cables are basically supports which are made of materials which are good in resisting tension. So we have discussed before in our lesson about supports that tensions are best are cables are good in resisting tensile forces. Okay, so let's go first to your engineering applications. Okay, so you have engineering applications for cables. So basically in engineering applications, one of the basic engineering applications are your for cables would be guy wires. Okay, guy wires in supporting high towers. We have discussed that before. If you can recall, if you have here a tower, okay, then your base is basically a ball and socket support or a hinge or whatever. Then your guy wires would be your supports which would help your tower be uh, on the state of equilibrium or making your high tower stable. Okay, so that is one basic application. Next would be suspension bridges. Okay, so I think you're very familiar with suspension bridge. Suspension bridge are bridges which are uh, very long and they are supported by um, a parabolic cable. Okay, so let's say this one is your supporting towers. You have here your supporting cables. Then you have your bridge deck. Okay, and then attached to these supporting cables are the cables which will support your bridge deck. One good example for this one is your Golden Gate Bridge at San Francisco or Brooklyn Bridge in New York. And then by the way, this is what you call suspension bridge. Another type of support for bridges would be what you call your cable stayed bridge. Now, the difference between cable stayed bridge and suspension bridge is the way these cables are installed. Okay, so for suspension bridge is something like this. Basically, your bridge deck are suspended or is suspended, while for cable stayed bridge, okay, your cables are installed such. Okay, so I think you have uh, you're familiar with this particular bridge. Okay, so it will be supported in that particular manner. Okay, and then of course last is another engineering application would be your transmission lines. Transmission lines for tawag ito, for electricity. So for example, you have here your poste ng kuryente, and then another poste ng kuryente, and then you have here your cable. It's the uh, electric or the kable ng kuryente itself. Okay, so those are basic engineering applications for cables. Okay, now cables are categorized by how it support loads. Okay, so categories based on how it supports your loads. Okay, based on loads application. Load application. So you have here two. Okay, First is if your cable is supporting a concentrated or set of concentrated loads. Okay? So for concentrated load, basically your concentrated load is applied somewhere along your cable. And then next is for category is when you are supporting uniform load. Uniform loads. Okay? So your uniform load can be uniformly distributed, or it can be the weight of the cable itself. Okay? So you have here two categories or two um, basic classification for uniform load. You have your uh, two basic classification for cables being subjected to uniform load. So first is your parabolic cables. Best example for parabolic cables is this one, your suspension bridge. And then of course you have your catenary cables. Okay, so best example for catenary cables are your transmission lines. Okay, so let's focus first on cable supporting concentrated loads. Okay, so cable supporting concentrated loads. Okay, so for cables supporting concentrated load, in this particular analysis, you have your assumptions. Okay, for a more conservative or convenient way of analyzing these types of structures. Okay, so you have here, first assumption is your cables are flexible. Flexible enough, sorry for the spelling. Flexible enough that it would not resist bending. So no resistance to bending. Okay? Next is the weight of the cables are negligible. Of cable is negligible. Compared to that of the loads being carried by the cables. Okay? So any point of or any portion of the cable between the successive loads is therefore considered a two-force member. So having these two assumption, let's take for example, or let's visualize this one by making use of this illustration. So let's say you have here your cable, okay? Your cable which is or which would be having this particular configuration due to your applied loads. Okay, your applied load, let's say here you have here an arbitrary load of P1 and P2. Okay, so if they are attached, let's say, to a pin, okay, and then a pin on the other side also. Okay, so since that one, then those your supports are pins, then basically you would have here your supports having their reactions. Okay, vertical reaction and horizontal reaction. Okay, so if this one is point A, point B, point C, and then point D, then you would have here vertical reaction at A, horizontal reaction at A, vertical reaction at D, horizontal reaction at D. Okay. So again, going back, so any portion of the cable between successive loads, so you have here successive loads, is therefore considered a two-force member. Okay? So therefore, internal force at any point in the cable reduced to a force tension directed along the cable. Okay? So if you were to take a section, or if you were to analyze, since it is a two force member, then if you can calculate, or if you can separate this one, take it as one free body. Okay, so if you were to isolate this one, take that as a free body, you would have here your free body diagram for that particular section to be something like this. So you have here load P1, and then you would have also your cable on that particular portion. Let's denote that one as cable AB, and then cable BC. Okay, so since you have you have passed a section on those part of your cable, then you should reflect the tensile force acting on each cable. So you have here tension at cable AB, and then tension at cable BC. Okay? Now, since this one is on the state of equilibrium, then you can calculate for this one by making use of summation forces along the x-axis and then summation forces along the y-axis. That would be equal to 0. Okay? So, moments for this particular segment of your cable cannot be developed. Okay? Now, since it is assumed that your cables is non-resistance to bending. Okay? Now, you can have the analysis by joint or by points, or you can have also the analysis, or you can also add the entire system as one free body in your analysis. That is for you to calculate for the reaction at your supports. Okay? So again, your equations of equilibrium, three equations of equilibrium is applied when you will be making use of this section or making use of the whole system as one free body. But if you would be taking joint by joint or portion by portion, then you are only limited to this particular equation of equilibrium.